All right, how did everyone do on the bell work? Good. All right, good. All right, today is Wednesday, October the 27th. Our last lesson of unit number 3. All right, make sure you got plenty of paper and your pen and calculator ready. Hopefully all of you have great algebraic solving skills. Solving systems of conics. Fun stuff. Okay, so system of equations that involves quadratic terms mostly. This can involve conic sections. Each equation has some quadratic term. This lesson will focus on the algebraic approach for solving a quadratic system. Most of the time, you will do a form of either substitution or elimination, or substitution or combination. Elimination and combination method mean the same thing. All right, let's get into the first one. All right, what type of conic is this first equation? Got an ellipse. How do we know? How do we know the type of conic it is? Like, what's the giveaway? Like, why would you say it's an ellipse and not something else? So the coefficients are not the same, and they're both positive. Yeah. By the way, this equation is not in standard or general form. This is neither standard or general. If it was in general, it would equal 0 by moving this 2 over. So yeah, they will give you equations that won't be in standard or general form, like this one right here. But it is an ellipse. We know it's an ellipse because they're both positive and they have different coefficients. That is a giveaway of an ellipse. All right, what is this equation? What does this make? Second equation. So what does this equation make? You tell me, is it even a conic? So I see a lot of you are saying circles, and if so, why? Like, why do you think this is a circle? So what is it? Enzo says it's a line. Brady says it's just a line. And those two are correct. It is just a line. Yeah, if and there's a minus sign. Yeah, a minus sign, there shouldn't be any minus signs in ellipses. Well, there can be, I guess, in parabola, but not really. Or circles. Yeah, this, and there's no squares. This is not x squared plus y squared equals 1. Yeah, there's no squares in here. So yeah, this is just the equation of a line. If you solve for y, you get y equals x minus 1. All right, when solving systems of conics, I highly recommend that you always graph them first. So go to Desmos and always graph these. So when we graph these two equations, you will get an ellipse and a line. So it's pretty clear that this first equation is the ellipse, It, it is the major axis is vertical. So it's a vertical ellipse. And the second equation creates this line right here. So always graph them first to kind of see what's going on. How many solutions will we find in this system? And how do we know it's 2? There's 2 intersections. Yeah, well, Brady, your reasoning is actually not true because you could have 2 variables and have like 4 answers. Yeah, exponents doesn't tell us either. So when you're solving a system, just because it has 2 exponents doesn't mean you have 2 answers. You could very well have more than 2 answers. You can have 3, you can have 4. So based on the graph, we have 2 solutions because it intersects at 2 places. So remember, back in the day, whether it was last year or year before, 8th grade, 7th grade, solving by graphing is the solutions are where the two graphs intersect. So we have a solution here and we have a solution right here. So we have 2 solutions. So that means when we solve this system, you should find exactly 2 solutions. You shouldn't find anything more or anything less too. All right. To solve by substitution, how do we do this? Ideas. Brady says solve for x, but x equals y plus 1. Okay. So if we do that, so let's do what Brady says and let's solve for x. I'm closing some windows I have open still. Okay, we solve for x. So x equals y plus 1, and then what? So Isaiah, you could also solve for y. It doesn't matter. And then we're going to plug that into the first equation. So we are going to plug this into our first equation for what variable, x or y? We replace the x with what it equals. Does this all look very familiar? Yeah, this is nothing new. It's harder because now it's conics and not something really straightforward and easy. All right, so everyone, let's quickly solve for y. See if you can stay a step ahead of me, or a step or two. So we're going to solve for y. Give all of you a moment. By the way, in chat, tell me, how are you solving for y? Which method are you using? Sure, you use algebra. All right. So how did all of you solve for y then? Use the quadratic formula? Did you graph it? Did you do something else? So how are you solving this? By the way, I avoid the quadratic formula like the plague if I can. I just don't like it. I think it takes too long. There's usually a better way than quadratic formula. But if that's what you use, that's fine. I just don't like it. So how did all of you? So it looks like Brady got y equals 1/2 and 3/4. So Brady, let me ask you this question. Okay. Now looking at the graph that hopefully you're using my graph or you graphed this in Desmos, this point right here and this point right here. So your two answers, y equals 1/2 and y equals 3/4, do these y values reflect your answer? Not really, because both of these y values are negative. So your answers are positive, which means you can't be right. Uh, um, yeah, my TGA questions aren't this straightforward. Mine won't be this easy. Mine's not just like tell me the solution to this system. So Rachel, hold that thought, and you'll see as we do more examples of why that graphing may not be the way to do it. All right. So I see a lot of answers in chat. How did all of you solve for y? How did you get the y values? So you graphed them. So you typed in this equation and you saw where it crossed the x-axis, basically, right? Yeah. So that's one way to do it, and you could do it that way if the answers it gave you were really nice. What if it gave you like an answer that involved like square roots? You probably couldn't use the graphing method. Let me else do a different method. Why couldn't you use the graphing? So let's say it crossed the x-axis at like 2.24 something or other going on forever. Do you know what that exact number is? Yeah, you don't. So that's where graphing wouldn't tell you anything. Because remember, we don't want to use rounded answers. We want exact, simplified, radical, or fraction form. Yeah, it's not a nice integer or rational number. Yep. So anyway, what's another way we could solve for y other than graphing? Come on, I'm not asking a very hard question. Sure, we use algebra. All right. Isolate the y. So do you want to solve by factoring? Do you want to solve by complete the square? Do you want to solve by like completing, or what do they call it? Factor by grouping? Like I'm asking you, how are you going to solve this other than graphing? All right, we are not sure. All right, so let's go ahead and distribute that 5 if you haven't already. So get down to here. We combine like terms. So in this step, the way that I'm going to approach this problem, so we could possibly solve by factoring, but I'm going to solve by completing the square. So I'm going to move the constant over to the right-hand side. And to complete the square, what do I have to do to this equation? We have to factor out the 8. Yes. So I'm going to divide everything by 8 to do that. Divide everything by 8. And leave some space. If you did your practice problems in the learn and practice modules, you should have came across problems where you had fractions when completing the square. So this shouldn't be new to anybody. All right. Complete the square. We're going to take that 5/4, we're going to divide by 2, and then we are going to square it. So we're going to add 25 over 64 to both sides. And then we factor it. So by doing complete the square, we know without thinking about it that this factors to y plus 5 over 8 quantity squared. And then negative 3/8 plus 25 over 64. You can do it in your head, or you can just type it in your calculator to get the number, which is 1 over 64. We are then going to square root both sides, plus or minus, and then we will then subtract 5/8 from both sides. Next, we have to write both of the answers. We must do negative 5/8 plus 1 over 8 and negative 5 over 8 minus 1 over 8. So we just type that in and hit enter, and we should get those two numbers, and then we have to simplify both of them. So we should get negative 3/4 and negative 1/2. Everyone doing good so far? Next, once you have your two y values, so before we do, let's kind of go over to the graph. And let's verify that these are correct. So looking at these two intersection points, it looks like it crosses at negative 1/2. Negative 0.5 is negative 1/2. There's that answer right there. So this matches this answer for the y value. Now we go to this one. Negative 3/4 is, well, decimal form is negative 0.75. And it looks like this point right here also matches. This looks like negative 0.75. And if you go to Desmos and you click that point, it'll tell you the decimal rounded value, which is negative 0.75. So this is nice. This is a great way to check our work halfway there. We can verify that these are correct. If these numbers don't match what your graph shows, something's not right. If they are both wrong based on the graph, you messed up. Now, if one of them is correct and one of them is wrong, that might be okay. And there is a reason for that, which I will get into in a different problem, I think, next. But if they're both wrong, you messed up. If one of them is wrong, you may be okay still. All right, next. What was more complicated, Brady? What was your way? The box, the x with a times c. I'm not really sure what you mean, Brady. Oh, you're saying you factored by doing the diamond method. That's what you're saying, right? Gotcha. Okay. Yeah. So we could have factored this possibly doing the diamond method, and that's fine. So, guys, this is only one way to do it. There's many ways. That's why I was asking all of you, how did all of you solve for y? Like, how did all of you get these two numbers? I did it by completing the square. You could have done it by graphing. You could have done it by the quadratic equation. You could have done it possibly by using diamond method. You could have done it by doing the monkey method. There is more than one way to do it. This is just how I did it. So, and remember, sometimes how I do it may not be the easiest for you or the fastest way. I just really like complete the square, and that's why I did it over factoring. Because, guys, a lot of times when you get a quadratic like this and you need to solve, factoring doesn't always work. Like if you can't think of the combinations that will make it work, you wasted all that time doing factoring method, or sorry, doing the diamond method or the monkey method or the factor by splitting the middle term or whatever it's called. Complete the square always works. Whether you have fractions or nice integers, it always works. So that's why I chose this, because I didn't even want to try to factor it. Hopefully that kind of explains my the rationale of why I did it this way, which may not be the easiest for you. All right. Next, what do we do? Once we have these two y values, what do we do with them? We plug each of them into the equation. All right. Do you want to plug it into the first equation, second equation, or we can even plug it into our second equation that we just reordered? Yeah, probably that bottom equation. Which is what I did. I plugged these numbers into our second equation, but I actually used this over here. And all we did was we moved this y value over. So yeah, I used that. But you don't have to. All right, so we plug in -3/4, and then we solve. So -3/4 plus 1 gives us 1/4. All right, so what is the ordered pair of that solution? (1/4, -3/4). Yes. And if you check, this coordinate corresponds to this coordinate right here. So that is correct. We always want to check the solution with the graph to see if these actually match up. Now, if this doesn't match up to our graph, something's not right. Either we didn't graph it right or we didn't do the math right. And then next we just do the other one. We plug in -1/2 and then we solve. -1/2 plus 1 gives us a half. So there's that solution. And this ordered pair does match up with this intersection right here. So we verified these are in fact correct. We did find two solutions. So we're done. That is it. That is solving a system using substitution method. Not too bad. Not too bad. These problems do get harder, I promise you. Okay, let's look at another one. All right. We want to solve again by substitution method. X squared plus y squared equals 16. X squared equals 8 times y plus 2. All right, class. What type of conic is this first equation? It is a circle. Yes, it is a circle. We know it's a circle because, well, a few things or two things. For one, we have x squared and we have y squared. They are both positive. So because of that, it's either going to be a circle or an ellipse. The second thing is that we don't have fractions and the coefficients are the same. So in this case, the coefficients are 1. So no fractions, coefficients are the same, 100% circle. What is this conic? for the second equation? It is a parabola. Yeah. We know it's a parabola because only one of the variables is squared. All right. So this problem, I do want you to do the substitution method. You could use elimination. I think elimination method for this problem is actually going to be harder than substitution. Okay, how do we do this problem then? Ideas, how do we approach this? No, it did not change, Isaiah. Let me click back and forward and maybe it'll reset yours. All right, so I'm seeing ideas in chat. I do see a really good idea. And then ideas that are close, but you're making things harder for yourself. All right, so Rachel's idea is actually the one that we're going to use. So let me just kind of mark on the screen what she's talking about. So if you didn't see what she wrote, but she's saying that, look, we already know x squared is equal to this. And in that first equation, we have x squared. So if we know x squared equals 8 times y plus 2, let's just replace x squared with that. So I'm going to go ahead and write that down. Oh, and by the way, of course, we always want to graph these first to see what's going on. We have a circle and a parabola, like we said. How many solutions will we find? We will find 2 solutions, yeah, because we have 2 intersection points. Right. All right, so we're going to do that. We're going to plug that. And now let's solve for y. So you can use any method that you want. Again, I like using complete the square, or maybe there's another method. So everyone solve for y. And then tell me what you get. Yes, based on the graph, the answers are easily picked out. I agree with you, but it's important that we go through the algebra because the problems coming up will not be this easy. You won't be able to pick them out from the graph. So what are so guys, we're solving for y. I see you guys are putting your answers in for x. We're not solving for x. We're solving for y right now. Yeah, it is pretty clear based on this graph that x is -4 and x is +4. You can even see, yeah, so we can easily pick out the answers from the graph, but let's solve it. So Rachel says the y equals 0. Anybody else? Okay, thank you. Thank you, Isaiah. Yes, you should have gotten two different answers. And Isaiah, how did you solve for y? How did you get those two answers? Okay, so you put it into Desmos to solve for y. Yeah, yeah, that is one way to do it. So Rachel, use complete the square method, and that will also work. Right. So I solve. Anybody else solve a different way? There actually is a faster way than graphing or complete the square. And when I show you what that method is, you're gonna wonder why you didn't see it in the first place. All of you are thinking too difficult. There is a much easier way to solve for y. Nobody, huh? All right, we can solve by factoring. Does everyone see that? We can solve by factoring. Yeah, factor out the y. And then you set the factors equal to 0. Because look at this. This is like the perfect scenario where it equals 0, we can factor out a y, and then we can set each factor equal to 0 and solve. So we get two solutions. I know. Sometimes the easiest solution is the most simple one. Yeah, so yeah, we got -8. And this is what I was saying, that when you graph this and we get these two answers, and we look at the graph and we say, hey, it makes sense that y equals 0 because we have y equals 0 here and we have y equals 0 here. However, this doesn't make sense because we don't have any intersections where, like down here, y equals -8 somewhere down here, and we don't have any of the graph even there. So let's see why this doesn't work. We're still going to use this in our next step, and we're going to show why this doesn't work. All right, so let's go ahead and plug these numbers into one of my equations. Which one did you all use? So when you complete the square, you only got y equals 0. Let me think. 8 divided by 2 is 4. 4 squared is 16. So you add 16. Square root of 16 is plus or minus 4. So Enzo, you should have had plus or minus 4 in your work. So you would have had y plus 4 equals plus or minus 4. So you should have gotten both answers. Okay, never mind. You got it. You're good. Hold on a second. Sorry about that. All right, so we're going to plug in. So I think I used the second equation. I think that one looked the easiest to plug in y. So we plugged in 0 into y to my second equation, and then we solve. All right. So here, what does x equal? Yeah, what does x equal? Yeah, plus or minus 4. There you go. Just want to make sure that all of you got the whole plus or minus, because whenever you square root both sides of an equal sign, when solving an equation, do not forget plus or minus. So that means our two solutions, when y is 0, we have two x values, one at 4 and one -4. So our two ordered pairs are just those. And these two coordinates match up to the graph. So these are correct. Now let's see the work for when it's -8. So we plug in -8, we do the math, and we do the square root. So what's the problem here? At this point, what's the issue? Yeah, it's imaginary. The square root of a negative number is an imaginary number. So this one is plus or minus 4i radical 3. Well, when you solve a system of equations, we only care about real solutions. So whenever you get something that's imaginary, we just ignore them because, well, they're imaginary. We only care about where they really intersect, not where they imaginarily intersect. I don't know. So yeah, they don't exist. So yeah. So we do not put those answers. We only care about the real solutions, the ones that you can actually see on a graph. Yeah, not too bad, right? Not too bad. Substitution method. Okay. All right, these are fun. So feel free to type these into Desmos if you'd like. Tell me, what is this conic? It is an ellipse, yes. And we know it's an ellipse because one, we have x squared and y squared. They're both positive, and the fraction portion of them, they are different. These are different numbers. Now, if both of these were the same number, it would actually be a circle. They're just trying to fool you by putting it in a non-standard or general form display of it. Remember, these kind of act like the radiuses for the x direction and for the y direction. And if these numbers were the same, they would essentially have the same radius, vertical and horizontal, which means it would be a circle, just not in the right form. So just because you have a system of conics doesn't mean that they will be in standard form or in general form. Our previous examples, they were not in that form. What is this conic? It is a circle, yeah. So in Desmos, when you graph it, how many solutions will we find? We're definitely going to find 4. And we know that because we have 4 points where our two graphs intersect. Now, if you type this into Desmos, you will discover by clicking these coordinates, they are not nice numbers. They are decimals that do not repeat and go on forever. So you are unable to pull out the solutions and avoid all of this work. Aren't you all excited for that? Nervous laughter. All right, we will use the elimination method here. So the elimination method, remember, looking at these, when you combine these, like we add straight down, when you combine these, either the x's or the y stuff will cancel out. So for example, if this is x squared, we want this one to be negative x squared, so they cancel out. If this is y squared, we would want this term to be negative y squared, so they would cancel out. So we probably need to do some scalar multiplication to, well, for one, to clear the fractions. So let's start there. How can I clear the fractions in our first equation? Yeah, our lowest common denominator. So what should I multiply by? Yeah, multiply the first equation by 36. Let's do that. Okay. Fractions are gone. All right, so we got 9x squared plus 4y squared equals 36. And then our second equation is this. So elimination method. We either want to make this term the opposite of this. So I want to make this to be negative 9x squared, or looking at this one, I want to make this term to be negative 4y squared. It doesn't matter what you choose. So what should I do to this one to get to one of those combinations? So multiply the equation of the circle by negative 4. So Enzo, so what's your reasoning? Why would you want to multiply by negative 4 and not say negative 9? Like, what was your reason? Because I did the same thing. I want to see if your reasoning is the same as mine. This is a long explanation. Because, yeah, because it's smaller. Yeah, that was my reason too, because it was smaller. We could have multiplied this entire equation by negative 9 or by negative 4, and I chose negative 4 because it's a smaller number. Yeah, because 9 times 7 is bigger than this number, right? So that is the only reason why I chose negative 4 instead of negative 9. Does that make sense? But it doesn't matter. We could have just done negative 9. All right, so look, now we multiplied this first equation by 36. We multiplied the second equation by negative 4. And now look at this. This is what we wanted. We wanted these, either the x's or the y's, we wanted them to be opposites, positive 4, negative 4. So when you combine straight down, the y squares get eliminated, hence the elimination method name. So we get 5x squared equals 8. And now what do we do? Yeah, we solve for x. So let's divide everything by 5. And then let's square root both sides. What's the square root of 8/5? Try again, Brady. Try again, Enzo. Make sure you rationalize. Remember, you can't have radicals in your denominator. 2 radical 10 over 5 is correct. Now, if you have a Casio FX 300 or 115, which I recommend, the 300 is 10 bucks, and you type in the square root of 8/5, hit enter, it will tell you the answer is 2 radical 10 over 5. I highly recommend getting one of those models if you don't already have one that can do that for you. There is no reason to do this by hand. But for people who like doing things the hard way, um, here's the work by hand. So you square root top and bottom. The square root of 8 is 2 radical 2. The square root of 5 is just, well, radical 5. And then you have to rationalize by multiplying top and bottom by radical 5. And that's how you get the answer. Okay, so what we can do now is we can convert this into a decimal, and then we can go to the graph in Desmos, and we can see, are these x value? Is this x value and this x value, is that decimal the same decimal that we get when we convert this into a decimal? It is. So that is a fantastic way to check to see if we are correct. And on a quiz, on a test, you better be doing that. Yeah. All right. So we verified that this answer is, in fact, this right here, this x value and this x value. And obviously this x value and this x value because they are in the straight line. We are now going to plug. Well, actually, let me ask you this. Now, what do we do? Once we have this, what do we do? Do we do the elimination method again or something else? Yeah, we're gonna plug it into one of my equations. Now, do you want to plug it into our first equation or the second equation? What looks easiest to you? Oh, you know what? I forgot to cover this up. Whoops. This should be covered up. I just noticed that. Whoops. Whoops. Let's pretend it was covered and I just uncovered it. We all knew it anyway. Okay. True, true. All right, so we plug in the plus and the minus into our second equation, and then we solve. So without typing this in, without typing in 2 rad 10 over 5 squared, do we already know what this is going to give us? Do we? We should, right? And what is it? Without actually doing the math, what is that number? All right, maybe I'm not asking it correctly, but so this work right here, when we're squaring this number without even typing it in, if we look back at this work here, isn't this the same thing as this right here before we actually square rooted it? So are we just kind of going backwards? So 2 rad 10 over 5 squared is 8 over 5. And if you didn't notice that, you just type it in. It only takes you like 10 seconds to type it in again and hit enter. But yeah, this squared gets you 8/5. I just wanted to point that out. I thought it was kind of funny. And by the way, there's the work if you did it by hand. But really, if you type it in, like you should be going from this step all the way down to this. Hopefully, you're not one to do it without a calculator unless you really want to. I showed it on the screen just because I don't use a calculator a whole lot if I don't have to. But yeah, we get these, and then we solve, right? So subtract 8 over 5 both sides. And then we square root. So this, again, you type it in the square roots. Oops, is equal to 3 rad 15 over 5. There's the work by hand, but really you should just type in the square root of this fraction, hit enter, and it should give you this answer right there. So that means there's the first two answers. When x is equal to 2 rad 10 over 5, we get those two answers. And then for the other two, we just have to solve just like we did before. And then there's the other two. 4 answers. So that was a good problem. That one you couldn't pull out from the graph. Oh, yeah, Brady. So yeah, you gotta be careful. Yeah, when you plug it in, remember this is x squared. So that's why that 2 is there. You're replacing x with what we found down here. But don't forget that square. That would definitely change your answer. Yeah, if you guys gotta go to the class, knock yourself out. I highly recommend coming back and watching the end of the recording later because there are some really good examples coming up. All right. All right, x squared plus y squared equals 16. What type of conic is this? It is a circle. Good. What is this conic? It is a parabola. Yeah, and we know it's a parabola because only one of them is squared. So we go into Desmos, we type it in, and we get this. So let me show you something about this problem. So elimination method, I multiply the bottom one by negative, and then we start going through it. So let me just quickly run through it on the steps. So I do complete the square. We get this. We do the math. I get, and this is my answer for y. It doesn't look very nice, does it? So then we have to plug it into one of my equations. I plugged it into the first equation. Plugged into my first equation. Why would I do that? It doesn't really matter. It's going to be a disaster anyway. So then it probably would have been easier to plug it into the second equation and not the first one, now that I'm looking at it. But the result's still going to be the same. At some point, after I FOIL this out and I get this and I combine like terms, we get down to this, and then we get here. And then I stop here because we have to do the square root of a number that already has a square root. And it makes the problem extremely difficult and very, very long. So I stop because you're not going to have one like this. It's beyond the scope of this class and the difficulty of this class to be able to have you do something like that. If you want to try it, knock yourself out. I stopped just because I got to here and like, yeah, it's not very fun. It becomes nearly impossible, not nearly impossible, but pretty close. Yeah, so yeah, either way it's a mess, Brady. So you won't have a problem like this where you'll be in a situation where you get to do a square root of something like that. It just won't happen. It is possible, but we're not going to do it. So we're skipping this one. But there's the work of why we skip it. Okay, here's a good one. So we got two problems left. So this is the substitution method still. Oops. Okay, so we're back to substitution method. All right. This conic right here, what do you think this is? So it's not a parabola because look, y squared and x squared. We have x and y are both squared, so it could not be a parabola. Cannot be a parabola. Yeah, so Enzo's right. It is a hyperbola. It's a hyperbola because one of them is negative. Y squared, x squared, one of them is negative. It tells us it's a hyperbola. And then what is this equation right here? What type of conic? It is not a circle. Nope, it is definitely not a circle. It is an ellipse. And we know it's an ellipse because, well, x squared and y squared are both positive, but the coefficients are different. Coefficients are different. Because of that, this is an ellipse. Now, this is not in standard form. So our last step here is to divide everything by 209 and reduce it. But yeah, this is not standard form. This is also not standard form. So different coefficients, both positive. It's an ellipse. And then when in doubt, you can always just graph it. See that we have a hyperbola and an ellipse. So we're going to have 4 solutions. And if you graph this one, you can actually pull out the answers right from the graph. They're really nice. All right, ideas on how to solve this problem. Yeah, graphing definitely be the easiest way because we can't pull out all 4 solutions. But other than graphing it, what should we do? Because I do want you to use substitution method on this one. So what do we do? So Brady says, I say eliminate the 5x squared and solve for 21y squared equals 9. Okay, so how can we eliminate this? Add both equations. Yeah, so here's a problem. If you just like combine, so remember we're using substitution, but it looks like you want to use elimination. So if you combine these together, we're going to have 7y squared plus 21y squared is 28y squared. Negative 5x squared plus 5x squared. Those cancel out, but we still have this 20x. So we're going to have a y squared, an x term, and a constant. That's a problem. You can't do that. So whenever you use elimination method, it should eliminate one of the variables altogether, not just part of the variable. So that, yeah, we couldn't do that. So let's use substitution method. So let me give you a little hint here. So we have x squared, y squared constant. Here we have y squared, x squared, and x. So we have x squared and x here. So let's maybe get these two on the other side. So let's start there. Let's move these two to the other side. I'm going to write that down. All right. So far, so good. Now it might be easier to kind of look at it this way. So we have the y stuff on this side, all the x stuff and constant on this side. Now, if you look at the second equation, if we can somehow replace part or all of this term with what it equals, we will then only have x's in our newly created equation. Does everyone see that? So multiply it times 3. So Enzo, tell me, so why would we want to multiply this equation by 3? Because then, yeah, then the left side becomes 21y squared. So let's go ahead and do that. Let's multiply this equation by 3. So far, so good? Yeah. Now, can we replace this 21y squared with what it equals right here? Can this piece become this? Yes, it can. So let's go ahead and do that now. Okay, so at this point, it looks pretty easy. So let's go ahead and solve for x, and I will do the same thing. Let's see if you can beat me. Oops. hate when it does that. So we do 3 halves plus 7 halves is 10 halves, and 10 halves gives us 5. And then 3 halves minus 7 halves gives us 7, 6, 5. Negative 4 halves, which is negative 2. All right, everyone get the same thing I get? You may have beat me, but you're wrong. So I did complete the square, though this one we actually could have factored. So we could have reduced it and had x squared minus 3x minus 10, and we could have solved by factoring. That actually would have been faster than complete the square. All right, so we know the two x values, so now we're going to plug it into one of our equations. It looks like probably the second equation looks easier. So we would want to plug it into that. So we'll do that. So we get 5. Oh, we solve for x, right? Oh, you know what you know what I did? Oh no, never mind. I'm fine. Thought I messed up, but I think I'm okay. Yeah. Okay. So we're gonna have 5 times 5 squared. Okay, plus all right, so we plug it in and then we solve. So everyone quickly do that. See if you can beat me and this time and not make a mistake. Dun, dun. So 5 squared is 25 times 5 is 125. Minus 125. What is that? 80 something? 84 maybe? Then divide by 21. And then square root. So that means my first two answers will be 5 comma negative 2 and then 5 comma positive 2. And we still have to do it again for negative 5. I think I actually have the work on the next page. I do. Let me just show that work to save time, even though we're already over. So here's this work. All right. Good stuff, right? Oh, did I have a typo somewhere? Oh, yeah. Sorry. Thank you. Yeah, I meant -2, not 5. So we did it with 5 already. We have to do it with -2. Sorry, I misspoke. Thank you. All right. So the reason why I didn't show my work to begin with is because this way makes more sense than how I originally did it. And let me show you how I originally did the first part. Um, so originally I did this, and so that is for the second equation. And then I solve for y. I'm not really sure why I did it this way. I don't think I was thinking very clearly the night that I typed this and did this. Um, I'm making the math harder than it needs to be by solving for y squared and then replacing y squared with that fraction stuff. Because then when you multiply, the seventh through. So I reduce. So let me show you what I did here. Reason I go from 7 to a 3 is because using 21, I reduce this 7 by a factor. What did I do? Oh, okay. Sorry. Multiply this times both of these to get these numbers here. And then from this step, I multiplied the entire thing by 3 to clear the fraction. That's what I did. And now I don't have fractions, and then the problem is done just like before. But you can see doing it this way, it overly complicates things because we have fractions, and it would just been easier to do what we did here. I sure did, Enzo. So yeah, fun stuff. I do have one more, but we are actually over by quite a bit, and I think you guys are probably tired of math. It is a quite easy problem. Let me just go through it with you guys. Oh wait, we did that one already. We going backwards? Have we done this one yet? I feel like we did. Okay, sorry. So this problem here, we have a hyperbola and we have a circle. In Desmos, that's what it looks like. How many solutions will we have for this system of conics? 0. So when you graph it, if you notice that they don't intersect, don't even attempt it. There's no point. This one has no solution. So we would write no solution or no real solutions, and then we go on. It's because they don't intersect. I just want to show you that if that ever happened to you. All right. Now this is our last one. Any method. Which method looks the easiest? Elimination actually would work if everything was lined up properly. Elimination would also work, but substitute. It's already set up for substitution. We would replace this x squared with what it equals. So this becomes 10y. Then you would have 10y minus 6 equals negative 2y. So let me just quickly run through that. This is probably the easiest problem on this page or on this lesson. So replace it, and then we solve. Divide by 12. We get 1/2. Then from here, we plug it into one of our equations. It probably doesn't matter which one. I think I did it the first one. Yeah, so I replaced the first equation, 10y equals x squared. I replaced our y with 1/2, and then we solve. And then that's how you get plus or minus rad 5. So there's your 2 answers. All right, sorry this went on, which seemed like forever, but I thought it was important to really take our time going through this because it's kind of difficult. All right, guys. Well, thanks for hanging around. And as always, I hope you really learned something here today. I will see you all tomorrow for the review for unit number 3. All right, everyone take care.